Everyone, welcome to my reaction video about microprocessor and microcontroller systems. But before that, let me introduce myself first. So, I am Richelle G. Cereno, BIT 3A, Computer Technology. So now, I hope you will watch the video until the end so that you will learn about because as we go all throughout this video, it will talk only about the microprocessor and microcontroller. So just watch my video. So today I will share you my reactions and insights about the microprocessor and the microcontroller. So for you to know, it is my first time to hear the word microprocessor and microcontroller. So sounds interesting, right? So yes, exactly that. So for me, as I think it deeply, it is to design to perform a specific task. So of us are confused about those topic about microprocessor and microcontroller. So now let's begin with the microprocessor. Microprocessor simply consists of the processor, the ALU or the arithmetic logic unit, the instruction decoder, and a few registers which are used for store data for mathematical and logical operations. So for me, microprocessors is used an application where the task is not predefined and it is only assigned by the user. So mostly it is used in computers, mobiles, video games, TVs where the task is not fixed and it depends on the user. So, best example for this is the laptop. Laptop is used for media streaming, simulation, editing image, web browsing, gaming, editing, documents, and many more. So there are components of the microprocessor and the microcontroller. So first we have the CPU or the central processing unit. The second one is the I/O or the input or output pins. The next one is the address bus or the data bus. Next one is a memory, RAM and ROM, or the random access memory or random optical memory. Next one is the serial port, and lastly we have the parallel port. So those are the components of the microcontroller and the microprocessor. Those are the common components of the both. The microprocessor is used in the very extensive process, though it only contains the CPU or the central processing unit, but there are many other parts are needed to work with the CPU to complete a process. So these all other parts are connected externally. Thus, the advantage of microprocessor is that it has flexible structure, meaning to say we can decide the size of the memory or the input or output ports and can modify all the things which are connected externally according to the application. So now let's proceed to the microcontroller. So a microcontroller includes a processor, then next is the ALU or the arithmetic logic unit as well. Next is the registers. Next is the code storage spaces. Next is the flash memory. Then the ROM on the RAM. Then next is the input and output pins. Then the timers, the interrupt controllers, serial communication, and module, and etc. So the purpose of microcontroller is to perform specific tasks. So specific means where the relationship of input and output is defined. Example for this is the keyboards, the mouse, the washing machine, digicom, the pen drive, the remote microwave, cars, bikes, telephone, mobiles, watches, and many more. So, since the applications are very specific, they need resources like random access memory, the input and output ports, and etc. And now let's proceed to the historical background of the Intel microprocessors. So first we have Intel 4004 and it was in the year 1971. So it has 4-bit microprocessor and 4 kilobytes main memory, 45 instructions, then PMOS technology. So it was the first programmable device which was used in calculators. Next is Intel 8080 in 1973. It has 8-bit microprocessor, 64 KB main memory, then 2 microseconds clock cycle time and 10 times faster than 8008. Next is the Intel 8085 in 1975. So it has also the 8-bit microprocessor, then 64 KB main memory, and it uses only 5 volts power supply. Next is the Intel 8086 to 8088 in 1978 and 1979. So it has 1 MB memory. Next is 6-byte instruction and the 4 nanoseconds clock cycle time. Next is the Intel in 80186 in 1982. It has 1 MB main memory, 16-bit microprocessor, upgraded version of 8086, and never used in PC. Next is the Intel 80286 in 1983. It has 16 MB main memory, concentrates on the features needed to implement multitasking. The next one is the Intel 80386 in 1986. The Intel's first practical 32-bit microprocessor. It has 4 gigabytes main memory, the memory, paging, and enhanced input and output permissions. Then the next one is the Intel 80486 in 1989. It has 4 gig memory also and 32-bit high performance. Next one is the Pentium in 1993. So it has 32-bit microprocessor, 64-bit data bus, and 32-bit address bus. And it is the fastest version in the 233 MHz. Next is the Pentium Pro in 1995. So 32-bit microprocessor. It has also 64 gigabytes main memory and it uses the execution engines. Next one is the Pentium 2 in 1997. It has 32-bit microprocessor and it has 64 gigabytes main memory. Also, it has 32 kilobytes split instruction and data. And lastly, a version of P2 called Xeon. The next one is the Pentium 3 in 1999. So it has also 32-bit microprocessor, the 64-bit data bus, the 64 main memory, and it was available in clock frequencies up to 1. Next is the Pentium 4 in 2002. So it has 32-bit microprocessor and it has also 64 gigabytes main memory and specialized for. So that's all for the microprocessor and the microcontroller. So now I have a question for you. So did you understand about my video? Because for me, I am thankful enough and much appreciated that we molded technologies together and technologies as improvement in every generation. So we're gifted enough that we are living in technology nowadays. So that's all my reaction and insights about the microcontroller and the microprocessor, and I hope that everyone will learn from it. Thank you for watching and God